students. Welcome back to the lecture. So in this lecture, we'll try to see how the slab reinforcement has to be given. So far we understood about the beam reinforcement, right? So how to understand the slab reinforcement? For that, you can see it here. This is a slab layout what we have. But one thing, if you had carefully observed, you can see a lot of section has been drawn here. You see it here. What is written here? I, right? This entire green dotted line, what you can see, it's the entire section what they have cut. That is I section. Okay. Now in the same way, if I show you one more section, yeah, just concentrate here. You can see it here. Another one section has been cut here. So this is E section up to here. This is my E section. In the same way, if I go to the G section, you can see, if I try to zoom in, you see here, it's G section. It has been cut from here. And I think it has gone all the way, cutting all the slabs. So because different consultant use different ways of giving a steel, so that is why we have to follow this in this particular building. So it is given G here. So you can see it in this way. They've started from A and they're gone up to like G, H, yeah, K also we can see it here, right? Let me try to see where exactly the A is given. So maybe, yeah, we can see the B here. See the B cross section is here. You can see. Yeah, this is B cross section here, B. And similarly, we have a cross section here. Okay. Yeah. You can see the A cross section here in this part. So this is A here. It has gone up to here. So what exactly conclusion we are going to draw from here? So that means if I want to put a slab reinforcement in this particular area, I'll look into this AA section. Okay. That means we get another drawing for this. That is a cross section. You can see it here. Yeah. We have to go for the basement revised one. Yeah, you can see here basement revised roof slab section, and you can see whatever section we had seen, the same section they have mentioned it here. Like you see section AA, then we have a section E. Yeah, this is section EE. Then we have section BB, C, D, F, G, H. So in this way, all the sections has been given. So this is a bit complicated when compared to the other drawings. If you had taken my earlier, drawing reading course, there we had very simple slabs and we were able to understand that in a more better way. Since here the consultant has given in terms of section, now it becomes a bit challenging for us to understand. But anyhow, always a good thing if you understand. Now first we'll try to concentrate from here. Section AA is given. Good. So let me bring that drawing here also. I'll take this out. Yeah, basement roof slab section. It's not required. Yeah, this is the one we were looking, right? Yeah, revised one. So I'll bring it here and we can go together. Yeah. Yeah. So we'll go with the A section now. Okay. So if I go for the A section, just concentrate here. One, if you understand, it's always easy for us. A has been cut here. See through which beam it is cutting. It is cutting B75 beam, right? Again, it is cutting this particular beam. Cutting in the sense, see, I have a beam running here, and this green dotted line is going through that, right? So just mention if you are, if you have time or if you have a pen and paper, you can note it down so that we can verify. Cutting B86, it is cutting B95, B104. Then it is cutting even this beam, right? B113, and it has been stopped up to here. Now, when I go for the cross section part, so remember this B75 and B86. You see here, B75 beam they have drawn, B86 they have drawn, great. Then they have drawn B95 because we had a B95 here. Yeah. Then 104 and 113. Yeah. Then again 104 and then 113. Got it? So this is a cross section which with that A section is cutting. So that is why all the beams has been shown here. Now you are seeing it from the front side. Okay, that is why we can see only the depth and the breadth of the beam in this way. Yeah. Now again, what else we need to understand from here? After this, how your reinforcement will start for the slab. Okay, so it will start from here. That means one is your bottom reinforcement. You can see this bar. This is not your beam reinforcement. Okay, you may get confused that this is not your beam reinforcement. Okay, this is your slab reinforcement only. So you can see the bottom here. Okay. Okay. So what is given here? It is mentioned in the bottom. What kind of reinforcement? You can see the marking done here. Your two marking. One, you can see that dark circle, isn't it? So that is a distribution steel. I mean, not a distribution steel, because if it is a two-way slab, both are main steel. But for our understanding, I'll use a term called as distribution. But remember, if it is a two-way slab, both are main reinforcement. Now you can see here, this purple color, it is mentioned, you have to provide a 8 diameter bar at 6 inches center to center spacing. I'll draw it in this way so that we get a better picture once we finish this entire. Let me consider this is my slab, okay, and I'll consider this is my shorter span, this is my shorter span, and this is my longer span. Okay, always the bars will be placed in the shorter direction first. So again, I'll go with this thinking that my 8 diameter bar at 6 inches center to center by the main reinforcement. So I'll keep my, this is my 8 diameter bar. Okay, I'll keep it in this way, and it has been placed at 6 inches center to center spacing. Okay, yeah, got an idea. So this is my 8 diameter bar at 6 inches center to center spacing. Now come to this bar. So again, you can see it is in the bottom portion only. It's a distribution bar if it is a one-way slab. Otherwise, it is a main bar only, but it is in a longer direction. Again, here you have to make use of a 8 diameter bar at 8 inches center to center spacing. So practically how it looks, practically, let us say this is my 8 diameter bar. Now this has been placed at 8 inches center to center spacing. Okay, so my bottom reinforcement is done. Now come to the top steel. So this is your top reinforcement now. Got it? This is your top reinforcement. What does this line indicate? This is the center of your beam. If this is my beam, exactly from the center of my beam, I have to run this particular top bar. And how much extension it will go? 1 feet 6 inch. Okay, this will go up to 1 feet 6 inch. Similarly, at this portion, if you come, see whatever I have drawn, this particular slab, only for this panel I have drawn. Okay, this is okay. To put it in a better way, let me do one more thing. What I'm going to do is, yeah. So let us consider this is my B75. Okay, I'll draw it here. Yeah. Let us say this is my B75 beam. Okay, that is this B75, and I'll take one more color for B86 beam. No, I'll draw my B86 beam. I hope. Okay, I'll go with a different color. Yeah, same color there. Yeah, B86. I'll take this as B86. Now is it clear for you? Only this much portion only I've mentioned. I've taken it here. Yeah. Now you see this extra bar you have to provide. Okay. Now one thing you may get confused. In slab, how is that we are providing extra bars? We have different ways of providing a bar. You can give the top extra bar. Sometimes what we give is we give a crank bar, something like this, isn't it? In this particular building, we are not using crank bar, but we are giving a top extra steel. Now again, you can see here what is mentioned here. Up to 1 feet 6 inch, you are supposed to provide a 8 diameter bar at 6 inches center to center spacing. That means I'll give a top extra bar. I'll take a different color. I'll go with a black color now. So this much is my beam center. My beam center is here. I'll provide my top extra bar in this way. Okay, got it? Yeah. So till what distance it is going? Okay. Yeah. Yeah. Till what distance it is going to go? That is again mentioned in the drawing. Let us quickly do that. Yeah. So from the center, it has to be 1 feet 6 inch. Let us say from here to here, this distance will be 1 feet 6 inch. I'll write it here. 1 feet 6 inches. Got it? So this is your 1 feet 6 inch. Yeah. So again, it has to be a 8 diameter at 6 inches center to center spacing. Now, again, you can see one more distribution still given here. It's a 8 diameter bar at 8 inches center to center spacing. Now, where you're going to provide this steel? This steel will be provided in the top only, but this time you're going to change the direction. Instead of going in this way, you're going on the other side. That means this bar, no? This bar is going to come exactly here in this way. Okay, in this way it's going to come, and it will stop up to what distance? Up to this only. Wherever your this 1 feet 6 inch has gone, no? Up to there only this thing is going to come. Got it? So I hope your left portion is clear for you. Now come to the right portion. Here your extension will be up to 2 feet. This extension what you are going to provide, it is up to 2 feet. And for this we'll see what is mentioned. Yeah. Yeah, so this extension is up to 2 feet. Again, when it comes to the reinforcement, you have to refer here. Okay, you can see this is your top extra, but it is going in this particular panel and also in this panel. So refer here what is mentioned. It is a 10 diameter bar at 6 inches center to center spacing, and for the distribution it is not mentioned here. For the distribution we can take this only, that is 8 diameter bar at 8 inches center to center spacing. Okay, yeah. So what I'm going to do, again in this direction also I have to provide. I'll quickly take this. I'll go with the black color. So it's a, see here, it is mentioned here. Okay. It is mentioned here, but it's the same bar which is going here also, right? So it's a 10 diameter bar at 6 inches center to center spacing. Again, I'll put it in this way. Extra bar. Okay. Yeah. Okay. So up to what distance it is going to go? It is mentioned here 2 feet. That means from this beam center to here it is 2 feet. It is 2 feet. Okay. Yeah. Good. And now again the distribution still you have to provide a 8 diameter bar at 8 inches center to center spacing. See, they have not mentioned it here. Okay. For this particular bar, you cannot see any, dimension. I mean, any of this is not representing the top distribution steel. In that case, you can take this only. In that case, in the sense, and usually distribution steel will be 8 diameter bar at 8 inches center to center spacing. You can go with that logic only. Otherwise, they should have mentioned it properly. Sometimes they miss it in the drawing, but you can make a call to the engineer and you can get it clarified. Since we are not clarifying, we'll go with the same thing, assuming that it's a 8 inches only, 8 diameter bar at 8 inches center to center spacing. Got it? So in this way, your slab panel is going to look. So in the bottom, in the center portion, you don't have anything. Only your bottom reinforcement will come. Now, what is the logic behind this? Again, for the very same logic, this particular slab is going to behave. That means we have a negative bending moment. We have a positive at the center. We have a negative at the support. So if I put it in this direction, so this is negative, this is positive, and this is negative. Since we have negative bending moment here, your slab will try to lift up. So that is why you have provided the top steel. This top, whatever you have provided, 1 feet 6 inch, that is your top steel, which will take care of this negative bending moment. Now come to the center portion. Center, you have only positive bending moment. You don't require the top steel. That is why we have provided only the bottom steel here. Now again, come to the this thing edge portion, that is here near the beam. Again, what has happened? Since it is a negative bending moment, you have to provide the top steel. That is why we have provided a top steel here. You can see here this up to 2 feet, this distance they have given. No, that is why you have to provide the top steel. Got it? So that is the main idea behind this. And with this logic, if you see any of the drawing from here onwards, it's the same thing what you can see, right? So if I ask you to plot the bending moment diagram for this particular thing, obviously you will be in a position to draw it now. So quickly let me draw it. We'll start in this way. So we have a, see, always remember wherever you have this slab and a beam junction, your negative bending moment is going to come. So I have a beam here, I have a slab. Of course, it's a negative. I'll go with a different color. Yeah. And then we'll go with this. Yeah. So it's a negative bending moment. Got it? We have positive, positive. Again, from here, again, you have negative. And this is also negative. Because again, this is my beam. Here also I have a slab. Here also I have a slab. So this is a continuous. So you get a negative bending moment. Again, you're coming to the center portion. Positive. Again, it is a negative. Then positive. And of course, here it will be negative. Got it? So wherever there is negative, let me denote that with a different color. Okay, negative, 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 and negative. And wherever it is a positive, let me write this as positive, positive, and positive. Okay. If you want, I can draw one line which will bifurcate that. Okay, we'll say this is that line. Okay, above this is negative, we are positive. Got this? This is how the typical bending moment happens for all the slab panels. That is why this is how you get the steel. And wherever you just observe the trend here. Wherever you have this negative bending moment, you can see all the top extra steel has been given. So if I want to, if I can bring it down, and now you see the trend. See, we had a negative bending moment. So you're providing a top left extra, top right extra. You had a negative, you are providing a top extra. Negative, you have an extra bar. Sagging bending moment, bottom steel. Now one question may come in your mind. Wherever there is a negative, you told that top extra steel will come. Then why is that? If I clear everything, I'll clear everything now. Yeah, I'll go with this. Yeah. So if that is the case, then why is that we haven't got a top extra steel in this portion? Because here also we have beam. Here also we have beam. Here also the bending moment should have been something like this. Here also the bending moment should have been negative, then the positive and the negative. Here the bending moment is also similar to that. But what has happened? your 8 diameter bar, whatever you are providing in the bottom, that is sufficient to take care of your positive bending moment and the negative bending moment. That is why I don't require the additional steel here. Whereas in this portion, if I delete it, in the middle portion, let us say here, why is that we are giving a top steel and all? Because you can see a lot of negative bending moment, positive, and then the negative. Here what has happened? Here also negative, positive, and negative. But here the bending moment, whatever we are getting, no, the negative bending moment, it is a huge negative bending moment. If huge negative bending moment is coming, I require huge amount of steel. So that is why we are providing a more top steel here. Here also more top steel. Whereas if you come to this portion, if I delete this, whereas in this portion, the negative bending moment is very less. When there is very less negative bending moment, you don't have to provide the too much of steel. That is why you are not getting the top extra steel in this portion. Got it? So that is the main idea behind all these things. And that is how you're supposed to understand. I hope up to here your concepts are clear. I can take one more section to clear out, rule out any other doubts. So quickly, I'll take a small section. Okay. Maybe somewhere, no, almost all are okay. I'll go with a small section here. I'll go with a BB section. So this is my BB section now. If I cut it, which all beams I'm going to intersect? B74, B85, and B94. Only three I'll see. Okay, B74, B85, B94. So I'll go with the B section. This is section BB. You can see B74, B85, B94, and if I scroll it in this way, it will go up to here. You can see up to here. And what you can see here, see, it has mentioned here, we are getting a lift and a staircase. Maybe the same thing will happen here. If I go with the B section, we'll see what has happened. Exactly. You can see it is cutting up to here, isn't it? So you are getting a lift here. You're getting a staircase here. So no slab will come. And that is why they have shown it here. That is lift is coming and staircase is coming where there is no slab. Your slab will only end up to here. That is B122. So this is B122, wherever it is ending. Yeah. So you can see this particular beam is B122. Got it? Of course, after that, rest things remains the same, like I mentioned. Okay. Whatever I mentioned, same thing remains. Okay. And this is a basement slab level. They are going to give the all those levels and all, from what level it will start and all. I hope up to here your concepts are clear. Now to make your things easier, yeah, I can show you. If you come here, so you get an idea. This was my plinth beam top level, isn't it? If you remember, this was my plinth beam. After the plinth beam, we are done the casting of the column, and whatever details we are seeing, that is a basement slab. So from plinth beam top to this, what is the height? It is a 10 feet from here to this height. Plinth beam top to here, it is a 10 feet. It is mentioned here. Basement slab top level is 10 feet level. Got it? Now, with all this understanding, I'll take you to few of the practical drawings, so that practical site images for the same building which we had executed. So this is my retaining wall. Once the retaining wall is constructed, you can see these are my columns, and this slab centering, whatever you can see, no, this is my basement slab. Okay, I'll take you to the next. You see here, retaining wall was done. And here they have put up the slab centering for the basement slab. So all these are your basement slab centering, all these things, the beam reinforcement, whatever we had seen, 16 diameter, 16 diameter, 5 bar at the top, maybe at 16 diameter, 3 bar in the bottom. Everything they have arranged practically on the side. And yeah, now you can get a better idea. See, this is my plinth beam, agree? And this was a column what I casted, and this is a beam bottom what I'm putting. Okay. Now, if I go back to this particular drawing, it's the same thing which represents. See, this is my plinth beam top. Okay, I'll go in this way. Yeah. So see here. Yeah. So this is a plinth beam top. This is my plinth beam top here. From here to here, I have a column. So from all these other column, you can see here. Here, this is a column. Okay. And whatever slab I'm going to put, no, over this, I'm going to put the slab. Got it? So this is light level. And from here to here, from this, the top of the plinth beam, from the top of the plinth beam to the top of this slab. Till now, it's not completed. This will be how much? 10 feet. Okay. That is how we are supposed to understand this drawings and all. Now, again, you can see here. Yeah. So again, plinth beam, all this works has been carried out. This is a lift pit. Whatever lift we had seen it here. Yeah. In this drawing, where if I go back, Yeah, so you can see here we had a lift portion, isn't it? Not this one, this lift portion. So we had a lift here, this much 1, 2, 3 columns we had. So practically you can see that here, this is that lift portion what we are trying to understand. This was the column, this was the returning staircase portion, and then we had few other drawings. Yeah. So again, all this is the lift, okay? Lift column, 1, 2, 3, 4 columns for the lift. All this were your lift columns. Yeah, that's how it is, okay? So I hope you have got a better idea. Exactly. And now we'll come to this. We understood about the slab layout and all, right? If you remember, in the previous lecture, I told you how to understand this, basement roof slab layout. So if I, for example, if I consider this particular level, this is B51, then this is B110, B45, and B17. Why we need to understand this is because when you put the shuttering layout, so this is that shuttering layout, how it looks, okay? So this is that particular slab which we are looking. If I put it in this way, yeah. So I'll go in this way. We'll consider this. Yeah. So this is that particular slab. Let us consider this is that particular slab. So this beam, whatever you can see, it is B44. This is that B44. Okay. B44. This beam somewhere here. Now here I have a B110. So this is my B110 beam. Okay, where is that beam? In this, inside this, that beam will come. Then we have B50 here. Let us consider this to be B50. And of course, on the left side, what is that? B100. So this is my B100 beam. Got it? So this layout will help me to arrange the beams and the slab centering practically on the side in this way, so that this carpenters and all can arrange all those across spans and all in the better way. And of course, all these things has been covered in my construction methodology course. I have completely explained you how all this practically on the site it was executed for the same building in a more better way with lot of site videos and all. Okay, yeah. So other than that, I think most of yeah. Now coming to the reinforcement, you see the reinforcement now. Right now we understood the reinforcement, isn't it? That is how the section will cut and all. If I go back, yeah. So you can see this is how that was done, isn't it? B75, B86, and so you can see the practically the same thing will be here. If I strike it out, see here, you can see the bottom reinforcement here. Then this will be a top left extra, top right extra. I mean, this is a top extra bars. What you can see, you can see the bottom steel here. You can see in the center portion in this way. In this way, this is your bottom steel which goes, and then this is your top extra steel. You can see from here. This is a top extra. From here also top extra. In the same way, on the other direction also, your steel will go in this direction. You can see. Similarly, here also that direction of steel will go. Okay. So in this way, whatever was there in the drawing, the same has been executed practically on the side. Again, the same bending moment diagram also follows here. We know we have negative, negative, and positive, and that is how the execution is done practically on the side. Yeah. Yeah. So I hope up to here you have enjoyed the lecture. You were able to understand how the slab details has been worked out, and also how to understand this particular drawing and the reinforcement details. So in the next lecture, we'll go with the next floor, that is the first floor, second floor, and third floor. But everything remains the same since it's a commercial building and we are going to replicate the same thing. Maybe a small changes may happen in the plan, but when it comes to the reinforcement and all, everything is same. So from here onward, we'll try to go in a more faster way, and will not try to I'll not try to explain each and everything in a more detailed way like I mentioned here. Any doubt, you can put it in the comment section or in the message. We'll be there to answer out, right? Yeah. So we'll see you back in the next lecture. Thank you.